So thank you very much for joining us. We are going to talk about Strimzi, a project about running Kafka on Kubernetes. I am Paolo Patierno, and I am here with Jakub Scholz. We are both maintainers of Strimzi, and we are going to talk about it in the next few minutes. Let's start from Kafka. So Kafka is an open source project originally created by LinkedIn. And at the beginning, Kafka was defined as a publish-subscribe messaging system, because at the end, Kafka is a messaging system. But over the years, the use cases around Kafka are changed. There are more use cases about using Kafka for doing some analytics on data in real time. So today, Kafka is even defined as a data streaming platform. But at the end, Kafka is a distributed fault tolerance, high available commit log. But Kafka is not just about the brokers, so the components which are in charge to exchange the messages between the clients, so the consumer and the producer. But it's more a broader ecosystem with more components. On the right-hand side, you can see, for example, there is Kafka Connect, which is a framework for moving data between different systems using Kafka, like, for example, moving data from one database to another. You can also see Mirror Maker. Mirror Maker is used for mirroring data between two different Kafka clusters running maybe on two different data centers in the cloud, for example. Coming to the clients, so talking about consumer and producer and the APIs for the clients, there are a kind of low-level APIs, so consumer and producer API that you can use for developing your application for sending and receiving messages. But there is even a more complex API, which is the Streams API, for writing more complex application for doing some analytics in real time on the data flowing through your Kafka. So Kafka is able to ingest this data in real time, and you can use this Streams API for doing some complex processing, like filtering, mapping, and so on. There are also some third-party tools, so other tools in the Kafka ecosystem, which are not part of the Kafka upstream project, but can be used for interacting with Kafka. But why at this point running Kafka on Kubernetes? So on one side, we have Kafka, which is a system distributed by nature, and even the applications and the workloads using Kafka are also distributed and scalable by nature. On the other side, we have Kubernetes. Kubernetes provides a great abstraction layer for running your software everywhere. So you can run Kubernetes on bare metal, or you can run Kubernetes on any cloud provider like Azure, AWS, IBM, and Google. And you can move your software on any of these platforms, or on bare metal or on a cloud provider, if you have Kubernetes under it. So you have just using Kubernetes for running your application, and you can move your application everywhere. So Kubernetes enables the cloud native development. But having on one side Kafka and on the other side Kubernetes, people who has knowledge about Kubernetes, why they should learn more about Kafka and not using the knowledge that they already have about Kubernetes for running Kafka on Kubernetes? This is where Strimzi comes. So Strimzi is an open source project. It's a CNCF sandbox project since last year, more or less. And it's mostly focused on running Kafka on Kubernetes, as I already mentioned. So it provides some container images for Kafka, for Zookeeper, because Kafka needs a Zookeeper ensemble in order to work today, but even images for all the other components that are parts of the Kafka, of the Strimzi ecosystem, as we will see in a little bit. Strimzi provides some operators, so it's based on the operator pattern in order to deploy, handling your Kafka clusters, and even all the entities around Kafka. But we will see more with the demo that Jakub is going to show us. So Strimzi provides a really Kubernetes native experience for us in order to handle Kafka on Kubernetes. Why? Because it's not only about a Kafka clusters, but even about the users and the topics and even all the other Kafka components in the Kafka ecosystem. But why I say that Strimzi provides a Kubernetes native experience for Kafka? Because in Kubernetes, we have different objects, right? Like, for example, pods, stateful set, deployment, secrets, config map, and so on. They are the different Kubernetes native resource that the user can use today. But in Kubernetes, there is also a way for extending the Kubernetes API. So Strimzi provides some custom resource definitions in order to make real this Kubernetes native experience for Kafka. So it means that with Strimzi, we have a new Kafka resource. So you can create your Kubernetes resource of kind Kafka, where you can describe your cluster and all the configuration. But it's not just about Kafka, as you already mentioned, even for all the other components in the Strimzi ecosystem. Like, for example, you have resources for Kafka users and Kafka topic for handling users and topics in the cluster. But you also have Kafka Connect and Kafka Connector resources for deploying a Kafka Connect deployment, so all the worker nodes related to Kafka Connect, but even for interacting with Kafka Connect for running the connectors, which are the components needed for moving the data between the system using Kafka Connect through Kafka. Then there is a Kafka Bridge resource for deploying a bridge, an HTTP bridge, in order to allow HTTP client to interact with your Kafka cluster. So using the HTTP protocol. Then we have a couple of resources for mirroring, so Kafka Mirror Maker and Kafka Mirror Maker 2, because they provide the way to deploy the two different versions of Mirror Maker that today are in the Kafka upstream project, so for doing mirroring across Kafka clusters. And last but not least, we have a Kafka Rebalance resource, which is used for doing a rebalancing on the cluster, so moving the partitions across the cluster through the brokers in order to have a more balanced cluster and not having heavy loaded brokers compared to some other brokers that are not hosting partitions, so they have no traffic from the other clients. So it's a way for rebalancing the cluster using cruise control, which is supported by Strimzi. Say that I would like to hand over to Jakub in order to show you everything I just said in order to see how all this kind of stuff works using Strimzi.
Thanks, Paolo. Let me share my screen. And I'm here already connected to my Kubernetes cluster. And in this demo, I will really show you that deploying Kafka with Strimzi is fairly easy. If you ever worked with the operators before, you know that the first thing which we need to do is to deploy the operator. So to deploy Strimzi operator, I will use a script from our website. So https strimzi.io/install latest and my namespace is my project equals here, and that will install the operator for me. The installation really consists of all the usual files which you will find in installing applications on Kubernetes. It's the custom resource definitions for the custom resources mentioned already by Paolo. It's all the different RBAC files to give the operator the access rights, and then things like a service account. And then last but not least, it's the deployment, which actually contains the operator. So if I do now kubectl get pods, I can see the operator is already running. There are also other ways how you can install the operator. So on our website or on the GitHub page, you can download the YAML files directly to install it from there. We have also Helm chart, if that's your preferred way. And then Strimzi is also on the operatorhub.io, so you can also install it easily from there. So you can really choose whatever fits you best. And now, if you know the operators, you know that the next thing which I will do will be to create some custom resource. For those who don't know that much about operators yet, the custom resource really extends the Kubernetes API and allows us to add some own resources. In our case, I will be using here the Kafka resource. And when the resource is created, then the operator will see it and it will make sure that it deploys the Kafka cluster accordingly. And it doesn't just do the deployment and installation, but it will also make sure it is managed while it is running, it keeps running, and it can take care of things like certificate renewals, upgrades to new versions, and so on. The custom resource really serves basically as a blueprint for the Kafka cluster. This one is one of the more simple one. It really just specifies the version of Kafka which we should use, number of replicas. It configures the Kafka listeners where the clients will be connecting, some configuration. It configures the storage. And then because Kafka depends on a zookeeper as a kind of dependency to bootstrap the cluster and do some hard beating and leader election, then we need to deploy zookeeper as well. So zookeeper is part of this resource also. Now, what I will actually deploy is a bit more complex custom resource where I specify some more things such as how many resources should the brokers get. I configure the encryption and authentication and authorization to have security in the cluster. And then I can also enable, for example, the Prometheus metrics from here. And then I do the same for the zookeeper as well. And I deploy also something what's called Kafka Exporter, which helps with the metrics. And all I need to do to actually deploy the cluster is to apply the resource, and the operator will basically immediately see it, and it will start deploying the pods. So what we can see here is that it's already deploying the zookeeper cluster. So we can see zookeeper pods 0, 1, and 2. And the operator will wait until the zookeeper cluster is ready, until it is bootstrapped and prepared to work. And only when that happens, it will actually move to the Kafka deployment. So you can see that the zookeeper pods are now getting ready. And now it will provision the Kafka storage using the storage class and persistent volume claims. And we can see now the Kafka pods starting as well. And again, it will wait until the Kafka cluster is ready and available, and then it will deploy the entity operator. As Paolo mentioned, we have also custom resources for users and topics, and that's what the entity operator is responsible for. And as you can see, the whole process is quite fast. It really depends a lot on how fast your internet connection is and how quickly the container images will be pulled and so on. So now we can see that Kafka is there. The entity operator is now deployed. And when that is ready, it will deploy the Kafka exporter. And in this demo, I'm really showing just the deployment of the Kafka cluster, but more or less in exactly the same way, you can also deploy the Kafka Connect or the Mirror Maker, or for example, the HTTP bridge. So the entity operator is now deployed. Now just the Kafka exporter. And once the Kafka exporter is ready, then basically the whole cluster will be deployed and available. And we can check that by doing kubectl get Kafka. which shows us that we have this my cluster Kafka resource with 3 Kafka nodes and 3 Zookeeper nodes, and we can also do get it in YAML, and we can see that these are, for example, the addresses where the Kafka clients can connect. This one is using load balancers from the outside, for example, from my laptop. This one is from applications running inside the cluster, and then we can also see that the state of the cluster is ready. So now we have the cluster running, and we should deploy some application, right? So let's start by preparing some user for that application and the topic. And that's where we will use the entity operator. So for the user, we have the Kafka User resource. In my case, the user is named my user. And inside this resource, I can say that this user should be allowed to use TLS authentication. And I can also, because I'm using the authorization, I can also specify the authorization rules. So for example, in my case, I give it the right to send messages to Kafka topic, which is called my topic. And I allow it to consume the messages from this topic as well. And again, I just apply the resource to have it created. And because we selected that we want to use TLS client certificates for the authentication, then I can check, and there should be a secret called my user, which is the same as the username, which was created by the entity operator and which contains the authentication details for connecting to, for authenticating to the cluster. And when I check the details, what's inside the secret, we can see that it has basically the user key and user certificate, which I will use for authentication. And if I would choose some different mechanism, for example, SSL Scrum SHA for using username and password, then the secret will contain the password for authentication instead of the certificates. And so this is when you want to manage the users locally, but it's not the only option which we have. You can, for example, use for the authentication OAuth using OAuth tokens and manage the users centrally in your OAuth server. And you can use OAuth also for authorization, or for example, we have also an option to use Open Policy Agent for authorization. So that was the user. Next, we need to create a topic. For that, we have a resource called Kafka topic. And I'm great at creating unique names, so I call it my topic. It will have 12 partitions and 3 replicas. And I can also add the config section where I can specify all the different details for this topic. And again, I just apply resource to get the topic created. And the great thing about this is that I do not really need to remember all the commands from Kafka, all the tools, all the options, all the parameters, and execute them somewhere. But I really just have this custom resource in YAML, which I can use. And then with the topic and the user ready, we have to deploy the application, right? And I have here really just some simple Hello World producer and consumer, which run as a deployment. What's the nice thing is that because the entity operator created the secret with the credentials for the user, I really just need to mount the secret as a volume or use it as environment variable, and I can use the certificates from it for the authentication. So I do not need to copy them anywhere. I can really just use the Kubernetes API for this. And when I apply it, we can check that the pods are starting, and we can check in the log of the consumer that it is actually receiving some messages. As you can see, it's really just a sample application, so it's really just sending every second some hello world message, but yeah, that shows that it works. And the great thing about having the Kafka user and Kafka topic resources is that when you develop your application, you can basically take all these resources, the Kubernetes deployment, the Kafka user and the Kafka topic. You can, for example, store it in the GitHub together with your application, and then, for example, use some GitOps tooling to get that automatically deployed, and it can travel with the code together with your application through the test environments, production, and so on. And you don't really need to have some complicated installation guidebook which would explain how to create the topics or the users in Kafka. And I also wanted to show that while Strimzi makes it easy to deploy and manage the Kafka cluster, it's not really just something for playing locally. We really support the features which you need to run production clusters, and we have, of course, users using Strimzi in production. So, for example, what I get automatically out of the box are things such as Prometheus monitoring. So I can see here in my Grafana dashboard that I have 3 brokers, I have 186 partitions, I can see all the different metrics. Right now, of course, with the Hello World application, the throughput in the cluster is very small, but you get this all built in, including the Kubernetes, the Grafana dashboards, and some sample alerts and things like that. So yeah, that's it for this demo, and back to Paolo.
So thank you very much, Jakub. It was a great demo showing what is the kind of Kubernetes native experience for handling a Kafka cluster, right? So Jakub showed us some of the features that Strimzi provides, but Strimzi has a lot of features. So you can see here showing up different features like scaling up and scaling down easily. You can just change the number of replicas on your Kafka resource. You can even use affinity and toleration in order to define the nodes where you would like to deploy your Kafka brokers instead of other pods. You can even enable the encryption, so having TLS as showed by Jakub with clients, but even internally between the brokers. You have ACL handling for handling the writes for writing and reading from the topics for the users. As you already mentioned, integration with Cruise Control, Kafka Connect, the HTTP bridge, mirroring. Secrets are used for storing the credentials and certificates. You also have metrics from all the components. So from the operator itself, from Kafka, from Zookeeper, Kafka Connect, and so on. And we provide some Grafana dashboard that Jakub showed about showing all these metrics through Prometheus, of course. So these are a bunch of features or part of the features that Strimzi, of course, provides today. But other than the built-in features, we can also say that Strimzi really integrates pretty well with some other CNCF projects, like, of course, Kubernetes, also with the Helm, because we provide Helm charts for deploying Strimzi. There is, of course, the integration with Prometheus, exposing the metrics and showing them in Grafana. FluentD, for example, is support for Kafka that you can deploy on Kubernetes using Strimzi, of course. There is integration with Jaeger and Open Tracing for doing some tracing, so tracing. So getting some tracing information about the messages exchanged between clients through Kafka topics. And even integration with the OPA, so the Open Policy Agent for the authorization, so that you can specify and describe using OPA what are the topics that a consumer can read, the producer can write, and so on. And there is also integration with KIDA, which is pretty new in CNCF today, and it's a project for event-driven auto-scaling application. So you can auto-scale your Kafka-based application using a Kafka scaler provided by KIDA, and you can, of course, deploy your Kafka cluster alongside KIDA using Strimzi. So there is a great integration with all this kind of project in the CNCF family. At this point, what's the way, kind of a call to action for engaging with the community, with the upstream community in Strimzi? First of all, you can just go on the Strimzi website and download Strimzi, try it locally on some cloud provider, so on your Kubernetes installation. You maybe can find some bug running Strimzi and trying Strimzi, so it will be great submitting the bug. So you can open a GitHub issue in our GitHub repo, explain about the bug, and if you have a fix, it will be great that you could even open a pull request on the GitHub repo, so submitting your code. But you can even submit your code if you have some new ideas around Strimzi, so you want to propose some features to add to Strimzi itself. You can also help with the documentation. So not developing stuff, but writing documentation, improving the documentation that we have today. If you find some typos, if you would like to make clearer some part of the documentation that you didn't get well while going through the documentation itself. And you can even help translating the documentation in your language. So for making Strimzi easily available across the world in different languages. You can even join our chat room. We have a room in the CNCF Slack workspace. You can, of course, follow us on Twitter. We have a Strimzi Twitter account where we tweet about a new release, new blog post, new features in Strimzi. But you can also help us spreading the word. So talking about Strimzi and maybe the project where you are using Strimzi or some ideas that you have around Strimzi at conferences, at meetups, or even writing articles or blog posts. And if you don't have a place for blogging, you can of course, blog with us. So you can contact us and you can write your article on the official Strimzi website in our blog. So say that, what's the way for reaching the upstream community? Of course, there is the official website, so strimzi.io. There is a Strimzi organization under GitHub. It's an organization where all the components in the Strimzi ecosystem live. So like, for example, the operator, of course, the HTTP bridge, the OAuth library, but even some client examples for interacting with the Kafka cluster deployed by Strimzi. The Twitter account that I mentioned, and even the Strimzi room in the CNCF Slack workspace. We also have a mailing list in order to interact with us, just sending an email. So I guess that's all on our side. I really hope that you enjoyed this session and that you will go and try Strimzi, and we will be really happy to know from you, from having some feedback for improving this project and maybe engaging with us in the future. So thank you very much.
Thanks for joining our session. I hope this was useful for you. There are a lot of questions, so I will try to go through some of them. If I don't manage to answer your question yet, or if I don't get to it in the live Q&A, then in 30 minutes we have Meet the Maintainers session where you can join and we can continue the discussion there. And you can, of course, also ask in the Slack channels as well. And we are also running a Strimzi survey. So if you are interested to help us know more about your requirements and missing features and so on, then please go to our website. There you find the link and you can fill it in. So let's have a look at some of the questions which we got. First of all, are two questions which are a bit similar. One is whether there are plans to replace Zookeeper, and another one is whether there is any initiative for unifying common dependencies like Zookeeper, which are used in a different projects. So maybe the Kafka perspective is a bit different. So if you follow the Apache Kafka community, Zookeeper is being slowly removed from the Kafka project and should be not needed in the future. And since Strimzi focus on Apache Kafka, then we will basically follow that up. And as it is removed from Kafka, we will then use only Kafka and not need Zookeeper anymore. So that way we will just upgrade, and that would not deploy Zookeeper anymore. And I think the current time expectations are maybe around end of this year or beginning of next year when this might happen in the Apache Kafka project. Then another question was, did you try to run it with Istio? So I personally didn't run Strimzi with Istio, but we have users using Strimzi together with Istio. Strimzi right now doesn't kind of tightly integrate into Istio and run as a part of Istio. So the users who are using this both together, they always configure Istio to kind of exclude Strimzi from kind of the Istio sidecars and not use them to do all the traffic, and instead kind of route the traffic to Strimzi and the Kafka brokers as to an external application. So you can run it together, but it's not fully running Strimzi as part of Istio. Another question was whether there is any roadmap for all the different projects and features of Strimzi. If you go to our GitHub organization, there's a GitHub project which is used as a roadmap where you can have a look. And yeah, if you think we are missing something, then we can definitely add it. Right now in the Strimzi, there's a lot of work going on around UI, which would allow to manage Strimzi and Kafka itself, like the Kafka topics consumer groups. So that's, for example, one of the big things coming in the future. Then another question was, does Strimzi also include components such as ASR, REST proxy, Kafka manager? So we include some components, but not all of these. We have our own REST proxy, which is integrated into Strimzi. We have support for cruise control for balancing the cluster, and that's all built in. And as I said, we are working on the UI and some kind of REST API for also managing the things a bit more. So not all of these are really built in, but some of these are, and the rest can be usually connected really as yet another Kafka operator. So to be honest, you do not always need operator for anything. Some of these things are just easier to deploy as a regular deployment that, for example, includes schema registries. Then another question was, how would one perform performance tuning on Strimzi? For example, number of disks which can affect the performance, or if you can specify on which types should the brokers running. So you can definitely do it because Strimzi supports all kind of different environments, starting from the kind of basic Minikube environment, which the users can run locally, up to the big public clouds. These are not always enabled by default, but you can, for example, use affinity in the configuration to define on which nodes should the brokers be scheduled. We also support the JBot storage, so if you want, you can specify that you want the Kafka clusters to use multiple disks, and we will then just create these disks and mount multiple of them into single pod, and that way you can kind of use more storage or get better performance from the individual brokers. And you can also use most of the different Kafka configuration options to tune the performance. So the operator itself manages some of them related to things like TLS and listener configuration, but all of the different buffer sizes and number of threads and so on, you can easily configure it yourself. And that was the last question which I managed to answer. There will be a thread on the Slack where you can continue asking the questions. And as I said, in around 25 minutes, we have Meet the Maintainer session. So feel free to join there as well, and we can continue answering the questions there. Thanks for coming for our talk and Q&A.